In today's lesson, we are going to talk about how to solve linear programming problem using Simplex method. Trust me, if you pay attention, you are not going to watch this video twice before you understand how to solve linear programming problem using Simplex method. Okay, we have the linear programming question. To solve this question using the Simplex method, the first step is to identify your objective function. The objective function is this function that starts with max. Any function in this linear programming problem that starts with max is the objective function. So this is the objective. Let me represent as obj, objective function. Okay, and we have subject to. These are the constraints that the objective function is subject to. So let me call this constraint 1, first constraint. First constraint. This is the second constraint. And this is the third constraint. So the meaning of x1, x2 is greater than or equals to 0 is that we cannot have a negative constraint. Let me put it, non-negativity of constraint. That is, the constraint cannot be negative. Okay, having identified your objective function and the constraint, the next step is to what? Change the objective function and the constraint into standard objective function and standard constraint. How do you do that? You are going to introduce slack variable. And I want to tell you that the numbers of slack variable that you are going to be introducing depends on the numbers of constraints that you have, because each slack variable is going to stand for each constraint. So based on this question that you are given, I'm going to introduce 3 slack variable because I'm having what? 3 constraints. You can see. So each slack variable is going to stand for each constraint. So for constraint 1, you can use any letter, but I'm going to use x4. I'm going to use x3. X3 will go for constraint 1, x4 for constraint 2, and x5 for constraint 3. Okay. These are the slack variable that I'm going to be using. So let us change the objective function to standard objective function. So I'm going to have z for objective function. Z is equals to what? 23x1 plus 32x2 plus, now these are the slack variable that I want to introduce. So I'm going to have 0x3. All the slack variable will take 0 as their coefficient in the objective function. So I'm going to have 0x3 plus 0x4 plus 0x5. So all the slack variable will take 0 as their coefficient in the objective function. Now let us change the first constraint to standard constraint. So constraint 1 is what? 10x1 plus 6x2 plus, now the first constraint, the first slack variable, which is x3, it belongs to what? Constraint 1. So therefore it's going to take 1 as its coefficient. Therefore I'm going to have 1x3. You understand? Other constraint belongs to other slack variable will take 0 as their coefficient in on constraint 1. You understand? Because they didn't belong to constraint 1. So I'm going to have 1x3 plus 0x4 plus 0x5, you understand, is equals to the inequality sign. The inequality sign here we change to equals to sign. So I'm going to have is equals to 2500. Okay, let's change the second constraint to standard constraint. So I'm going to have 5x1 plus 10x2 plus 0x3 plus what? Because the second slack variable belongs to what? The second constraint. So it's going to take 1 as its what? Coefficient in constraint what? 2. So I'm going to have 1x4 plus what? 0x5 is equals to 2000. Is 2000. Let's move to constraint 3. So I'm going to have 1x1 plus what? 2x2 plus 0x3 plus 0x4 plus the third slack variable belongs to what? Constraint 3. So that will be what? 1x5 is equals to 500. So we have changed the objective function and the constraint into what? Into standard objective function and standard constraint. Having done this, the next step is to prepare our initial simplex tableau. This is how a typical simplex table looks like. We have the PJ, which stands for the coefficient of each variable in the objective function. We have the resource, which represents the problem, the basis variable that we want to solve, or the problem variable that we want to solve. And we have the CO, that is the coefficient of each the coefficient of the basis variable in the objective function. And we have the real activities, which are the output of each constraint. We have the real variable that are given to us, and the slack variable, that is the variable that we introduce, and the ratio, which is the fraction. And Zj is the total amount of outgoing profit as a result of exchange between 1 unit of column variable and 1 unit of the basics variable. And Pj minus Zj is the net exchange. Okay, let's fill this table. Don't forget that the real variable that was given in the question is x1 and x2. So I'm going to write x1, and this will be what? X2. Okay, the slack variable are the variable that we introduce. So that will be x1, that will be x3, x4, and x5. So I'm going to have x3, x4, and x5. So let's come back to the resource column. The resource will be the resource that we are first going to use up will be our slack variable. Are you getting it? The resource that we are going to be used up, that will be the first basis variable, and that will be x3, x4, and x5. So I'm going to have x3, x4, and x5. Okay, the coefficient of this variable in the objective function, that is the meaning of CO. The coefficient of the variables that we have here in the objective function. So if you trace it, for the coefficient of x3 in the objective function is 0. So I'm going to have 0 in this place. The coefficient of x4 in the objective function is 0. So I'm going to have 0 in this place. The coefficient of x5 in the objective function is also 0. So I'm going to have 0 in this place, in these cells. So we have gotten the values of the coefficient of the objective function. Now let's move to real activity level. The real activity level refers to the output of each constraint. So for the first constraint, I have 2500. So I'm going to have 2500 in this place. For the second constraint, I have 2000. And the third constraint, I have 500. So I'm going to have 500 in this place. Okay. To get the value of these cells which belong to column x1, go to your standard constraints. Look at the coefficient of x1 in constraint 1, constraint 2, and constraint 3. So to start, the coefficient of x1 in constraint 1 is 10. So I'm going to have 10 in this place. The coefficient of x1 in constraint 2 is 5. So I'm going to have 5 in this place. The coefficient of x1 in constraint 3 is 1. So I'm going to have 1 in this place. Okay, let's move to x2. The coefficient of x2 in constraint 1 is 6. So I'm going to have 6. The coefficient of x2 in constraint 2 is 10. So I'm going to have 10. The coefficient of x2 in constraint 3 is what? 2. So I'm going to have 2. So for x3, that is 1, 0, 0. So this one will be 1, 0, and 0. For x4, the coefficient of x4 in constraint 1 is what? 0. For x in constraint 2, 1, and in constraint 3, 0. So I'm going to have 0, 1, 0. So for x5, the coefficient of x5 in constraint 1 is 0. In constraint 2, it is what? 0. In constraint 3, it is 1. So I'm going to have 0, 0, 1. 0, 0, 1. However, you might be wondering that what is the essence of this table? The essence of this table is to determine our key elements. Key elements. In some textbook, you might they might put it as pivot element. It's also the same thing. Key element, the key row, and the key column. This is what we want to determine: the key element, the key row, and the key column. Okay, let's get the value of zj for column x1. zj x1. Zj is for the value of column x1 will be the product of the coefficient of the basics variable, which is 0, multiplied by 10 plus 0 multiplied by 5 plus 0 multiplied by 1. This will give me what? 0. So the coefficient the zj of x1 is what? 0. You understand? So let's get the zj for column x2. It will also be the same thing: 0 multiplied by x, the corresponding variable of x2, that is what? 6. So 0 multiplied by 6 plus 0 multiplied by 10 plus 0 multiplied by 2. This is also what? 0. So this column is 0. For the z, let's get the zj of column x3. Zj x3 is equals to 0 multiplied by 1, that is 0. 0 multiplied by 0, 0 multiplied by 0, that is what? 0. So this also will be what? 0. For column x4 is also the same thing, 0. For column x5, that is what? 0. So that is how to get the value of zj. You understand? You just have to take the coefficient of the objective function of the basis variable of the problem variable that we have here, and then multiply it with the corresponding variable that you want to get the value of its zj. Then you sum it together. That is how to get the value of zj. Okay, let us proceed. The next row here is pj minus zj. Okay, let's start. Oh, sorry. You see, we didn't put the value of pj. Don't forget that I told you that pj is the coefficient of each variable in the objective function. So the coefficient of x1 in objective function is 23. So I'm going to have 23 in this place. The coefficient of x2 in the objective function is 32. So I'm going to have 32 in this place. The coefficient of x3 in the objective function is 0. So I'm going to have 0 in this place. For x4 is also 0, and for x5 is also what? 0. So I've gotten the pj value now. Now let's calculate the value of pj minus zj. Pj is 23, zj is 0. So this will be what? 23 minus 0, that is what? 23. So for x2, 32 minus 0, that is 32. For x3, 0 minus 0. For x4, for x5, that is 0. The pj minus zj will tells us the key column element. The column to which the highest value of pj minus zj belongs to, that will be our key column element. You understand? The column to which the highest value of pj minus zj belongs to, that will be our key column element. And if you look at this, the pj minus zj for x1 is 23, we have for x2 32, and for x3 0, 0, 0, 0, and for x5. Now, if you look at this, what is highest positive value in this place? That is 32. So, and the column to which 32 belongs to is what? X2. So the key column now is what? This is the key column. This is the key column because the highest value of pj minus zj is 32, and 32 belongs to x2. So column x2 is what? Key column. Do you understand? The column to which the highest value of pj minus zj belongs to will be what? The key column. Okay, now we have gotten the key column, which is column x2. How do we get the key row? The key row is gotten by first taking the ratio. How do we get the value of this cell, which is the ratio? We are going to divide real activity level, which is the output of each constraint, by the corresponding value of the key column. So for these cells, I'm going to have 2500 divided by 6. That is 416.67. So the ratio is for these cells is 416.67. So to get the ratio of these cells, I'm going to divide 2000 divided by the corresponding key column element, that is 10. 2000 divided by 10 is 200. And the value of these cells will be what? 500 divided by 2, that is 250. This is 250. Okay, having gotten the ratio, the row to which the lowest value of ratio belongs to will be what? Our key row. You understand? The row to which the lowest value of ratio belongs to will be our key row. And if you look at this ratio, you can see that the least positive value among this ratio is what? 200. So 200, the row to which 200 belongs to will be my key row. You understand what I'm saying? So I'm going to circle this. I'm going to circle this. So I have gotten the key column and the key row. Now I want to tell you that the element that intersects both the key row and the key column will be the key element. You understand? The element that intersects the key row and the key column will be the key element. Now look at this. Which element intercepts both the key row and the key column? Yeah, it is 10. So the key element is what? 10. So the key element is 10. You understand? So now let us proceed with our solving. We have gotten our key element. As you can see, we haven't reached an optimal solution. For we to obtain an optimal solution, the value of our net evaluation must be less than or equals to 0. And if you look at the value of this net evaluation, we still have 32 and 23. So we have not gotten an optimal solution. That will make us to proceed to our first iteration. Okay, we have the table of our first iteration. However, I want to introduce to you the concept of entry variable and leaving variable. The entry variable is the variable which our key column points to, and the leaving variable is the variable which our key row points to. Now, among the program variable, among the resource is also known as program variable. They are also known as the used variable. You understand? So I only put it as resource. It is also known as the program variable. Among the program variable, we have x3, x4, and x5. If you look, the key row points to x4. So x4 will be leaving this program variable, and the key column points to x2. So x2 will be the entry variable. You understand? The entry variable is the variable which the key column points to. The entry variable is x2 in this place, and the leaving variable is what? X4, because the key row points to x4. So therefore, for easy computation, make sure that you put the entry variable at the top. So therefore, the variable that will be here will be what? The entry variable x2. So that will be x2 for this place. And since x4 will be leaving this place, the x4 will be leaving our program variable. So I'm going to have x3 follows, x3 and x5. Do you understand? Oh, I forgot to put the value of zj. So this one will be zj. Okay, let us start filling the table. Let's start with the column of the CO. Don't forget that I told you that CO is the coefficient of the program variable in the objective function. And the coefficient of x2 in the objective function is 32. So I'm going to have 32 in this place. The coefficient of x3 in the objective function is 0. So I'm going to have 0. The coefficient of x5 in the objective function is what? 0. So I'm going to have 0 in this place. Okay, let's proceed to real activity level. I want to tell you that to get the new value of row x2, I'm going to divide all the elements on my key row by the key element. Don't forget that the key element is 10. The key element is 10. So to get the new value for these cells, don't forget that the key row is this place. This is the key row. So to get the new value of the real activity level for 2000, the new value will be what? 2000 divided by 10. Let me put it here. The new value of 2000 is equals to 2000 divided by 10. The 2000 divided by 10 is 200. So the new value of these cells is 200. Okay, let's proceed to these cells. To get the new value of these cells, don't forget that the old value of the cell is 5. So I'm going to have 5 divided by the key element, that is 1 over 2. So the new value of these cells is what? 1 over 2, that is 0.5. Okay, to get the new value of these cells, which old value is this? I'm going to have 10 divided by 10, so this will be 1. To get the new value of these cells, I'm going to have 0 divided by the key element, that is what? 0. That is 0 divided by the key element, that is 0. To get the new value of these cells, you can see that I'm going to divide 1 divided by 10, that is 0.01. And to get the new value of these cells, I'm going to have 0 divided by the key element, that is 0. Do you understand? This is what I did. To get the new value of the entry variable is variable x2. I'm going to divide the key row from my initial simplex tableau. I'm going to divide the key row by the key element. So to get the value of these cells, I divide 2000 divided by the key element, that is 10. So 2000 divided by 10, 2000 divided by 10, that is 200. 5 divided by 10, that is 0.5. 10 divided by 10, that is 1. 0 divided by 10, that is 0. 1 divided by 10, that is 0.01. And 0 divided by 10, that is 0. You understand? So let us proceed. To get the new value of this row x3 now, I'm going to give you this formula. The new value, let me call it NV, new value is equals to old value, which is OV, minus corresponding key row element, multiplied by corresponding key column element, all over the key element. This is the formula that you are going to use to compute the new value of the other elements. You understand? This is the formula that we are going to use to compute the values of the other cells. Now let us start. To get the new value of these cells, don't forget that the old value of these cells is what? 2500. You can see x3, the real activity level, that is 2500, the old value. So to get the new value of these cells, that is old value, which is 2500, minus the corresponding key row element. The corresponding key row element is 2000. You understand? I'm supposed to circle it to this place. I'm supposed to circle it. The circle extends to this place. You understand? Sorry. The circle extends to this place. You understand what I'm saying? So, okay, let's proceed. To get the new value of 2500, we're going to have 2500 minus the corresponding key row element. This is the new value that we're going to get. The corresponding key row element is what? 2000. When you trace it downward to the key row element, you are going to get 2000. The corresponding key row element is 2000. Multiplied by the corresponding key row element. We are going to trace it from this point, from the point where 2500 is. We are going to trace it to the key column. The element that is there is the corresponding key column element, and that is 6. So I'm going to have 2000 multiplied by 6 all over the key element. Don't forget that the key element is the element that intersects both the key row and the key column, and I've already written it here. So the key element is 10. You understand? Okay, let's proceed. 2500 minus 1200. So the new value of 2500 is what? 1300. So the new value of these cells is 1300. Okay, let us proceed to get the new value of these cells. Don't forget that the old value of these cells is what? 10. You can see the old value of these cells is 10. So to get the new value, we are going to use the same formula. To get the new value of 10, we are going to use the same formula, which is the old value, that is 10, minus the corresponding key row element. We are going to trace from 10 down to the key row element, and the corresponding key row element is what? 5. So I'm going to have 5 multiplied by the corresponding key column element. You are going to trace from 10 to the key column element. So the corresponding key column element is 6. So because if you trace from 10 to this side, you are going to get 6. The key column element is 6. So I'm going to have 5 multiplied by 6 all over 10. If you punch your calculator, you are going to get 10 minus 7. 10 minus 3 is equals to 7. So the new value of this cell is what? 7. Okay, let us get the new value of these cells. The old value is 6. However, I want to tell you that every element that is on top of our key element or below our key element is always 0. The new value of such element is always 0. If you want to check, I can check. Let's proceed. To get the new value of these cells, as you can see that 6 is above our key element, which is 10. Now let us try to get the new value. The value will be 0. Let's see. That will be new value is equals to old value, which is 6, minus the corresponding key row element. The corresponding key row element of 6 is what? 10. Because when you trace 6, when you trace it down to the key row element, you are going to get 10 as the corresponding key row element. So I'm going to have 10 multiplied by the corresponding key column element. The corresponding key column element of 6 is 6 himself. You understand? Because this is the key column element and 6 is the corresponding key column element of itself. So I'm going to have 10 multiplied by 6 all over the key element. The key element is what? 10. So that will be 6 minus 6. Because when you divide this, you are going to get 6. 6 minus 6, that is 0. So the value of this place is 0. I've already told you that every element, you don't need to calculate this. You understand? Every element that is on top of our key element, that is, every element that is on top of our key element or below our key element, the new value of such element is always what? 0. So let us proceed to get the new value of these cells. The old value of these cells is what? 1. We are going to use the same formula, which is old value, which is 1, minus the corresponding key row element. I'm going to trace it from this 1 to the key row element. The corresponding key row element of 1 is what? 0. So I'm going to have 0 multiplied by corresponding key column element. The corresponding key column element is what? 6. So I'm going to have 0 multiplied by 6 all over the key element, which is 10. That is, if you punch your calculator, you are going to get 1 minus 0. That gives me 1. The new value of these cells is 1. Okay, let us proceed. To get the new value of these cells, the old value is what? 0. So using the same formula, we are going to have 0, which is the old value, minus the corresponding key row element. You are going to trace it downward from 0. The key row element that corresponds to 0 is what? 1. So I'm going to have 1 multiplied by the corresponding key column element. We are going to trace it down from back from 0 to the key column element, and the corresponding key column element that corresponds to 0 is what? 6. So that will be 1 multiplied by 6 all over 10. If you punch your calculator, you are going to have 0 minus 3 over 5. That is minus 3 over 5. The new value of these cells is what? Minus 3 over 5. Okay, let's proceed to get the new value of these cells. The new value of these cells will be what? The old value, which is 0, minus the corresponding key row element, which is 0. So I'm going to have 0 minus 0 multiplied by the corresponding key column element. The key column element that corresponds to 0 is what? 6. So 0 multiplied by 6 all over 10. That will be what? 0. All of them 0. So the new value of these cells is what? 0. So we have already gotten the new value of row x3. Let us get the new value of row x5. We are going to use the same approach to get the new value of these cells now. The old value is 500. So I'm going to have 500, which is the old value, 500 minus the corresponding key row element. I'm going to trace from 500, I'm going to trace it to the key row element. The element that corresponds to 500 is what? 2000. You understand? So I'm going to have 500 minus 2000 multiplied by the corresponding key column element. The element that corresponds to 500 from the key column is what? 2. You can understand? So I'm going to have 2000 multiplied by 2 all over the key element is 10. So I'm going to have all over 10. That will be what? 500 minus 2000 times 2, that is 4000. 4000 divided by 10, that is 400. 500 minus 400, that is, the new value is what? 100. So the new value of these cells is 100. So you understand, that is how you are going to get the new value of the remaining cells. So to get the new value of these cells, don't forget that the old value is what? 1. So I'm going to have old value, which is 1, minus the corresponding key row element. I'm going to trace it upward from this 1 to the key row element. So the corresponding key row element is 5. So I'm going to have 5 multiplied by the corresponding key column element. I'm going to trace it from this 1 to the key column element. The element that corresponds to 1 from key column element is 2. So I'm going to have 5 multiplied by 2 all over 10. If you punch your calculator, you're going to get 1 minus 1. That is what? 0. So the new value of these cells is what? 0. So to get the new value of these cells, don't forget that I told you that every element that is below or above our key element, their new value is always what? 0. So therefore, the old value is what? 2. And you can see that this element falls under the key element, which is 10. So the new value is what? 0. You can proceed to check as I check for 6. The new value is always what? 0. Now let us proceed to the next cells. Okay, to get the new value of these cells, don't forget that the old value is 0. So I'm going to have 0, which is the old value, minus the corresponding key row element. I'm going to trace it upward from this 0 to the key row element. The corresponding key row element is what? 0. So I'm going to have 0 multiplied by the corresponding key column element. I'm going to trace it from this 0 to the key column element. The element that corresponds to 0 from key column element is what? 2. So I'm going to have 0 multiplied by 2 all over 10. So the answer is what? 0, because 2 multiplied by 0 is 0, 0 divided by 10, 0, 0 minus 0, that is 0. So the new value of these cells is what? 0. Okay, let's get the new value of these cells. Don't forget that the old value of these cells is what? 0. Now to get the new value, we are going to have the old value, which is 0, minus the corresponding key column, the corresponding key row element, which is 1. That is 0 multiplied by 0 minus 1 multiplied by the corresponding key column element. We are going to trace it from this 0 to the key column element. The element that corresponds to 0 from the key column element is what? 2. You understand? So I'm going to have 1 multiplied by 2 all over 10. So if you punch your calculator, you're going to have 1 minus 2 over 10. And this can be reduced as what? Minus 1 over 5. So the corresponding, the new value of these cells is what? Minus 1 all over 5. Now let us get the new value of these cells. Don't forget that the old value of these cells is what? 1. So using the same approach, I'm going to have old value, which is 1, minus the corresponding key row element. I'm going to trace it from this 1. I'm going to trace it to the key row element. The key row element that corresponds to 1 is what? 0. So I'm going to have 0 multiplied by the key column element. I'm going to trace it from this 1. I'm going to trace it back to the key column element. The key column element that corresponds to 1 is what? 2. So I'm going to have 0 multiplied by 2 all over the key element. So that is 1 minus 0. The new value of these cells is what? 1. So because 1 minus 0 is 1. Okay, let us proceed. We have gotten the new value of these cells, of this programmed variable. Now the next step is to calculate the value of zj. I told you that to get the value of zj for each variable, we are going to multiply the coefficient of our resource, that is the coefficient of our programmed variable, multiplied by each variable and then add it together. So to get the zj of x1, zj x1 will be equals to what? Coefficient of the program variable, that is 32 multiplied by 0.5, 32 multiplied by 0.5 plus 0 multiplied by corresponding x1 variable, that is 7, 0 multiplied by 7 plus 0 multiplied by 0, 0 multiplied by 0. So zjx1, 32 multiplied by 0.5, that is 16. 16 plus 0 plus 0, that is 16. So the zj of x1 is what? 16. Do you understand? So let's get the zj of x2. So to get the zj of x2, which is the value of these cells, I'm going to have 32 multiplied by corresponding variable of x2. That is 1. 32 multiplied by 1 plus 0 multiplied by 0, that is 0, plus 0 multiplied by 0, that is also 0. So that is 32. So the zj of these cells is what? 32. Using the same approach, you are going to get the zj value of x3,
x4 and x5 respectively. Just follow the same step.
Okay, now we can evaluate our pj minus zj, which is net evaluation. Now let us start. Pj for these cells is what? 23. Zj is what? 16. 23 minus 16, that is 7. So the value of pj minus zj is what? 7. Okay, the pj of this column is what? 32. 32 minus what? Zj is also what? 32. So the 32 minus 32 is what? 0. For this I'm going to have 0 minus 0, that is 0. For this I'm going to have 0, which is pj for this column, minus 3.2, that is minus 3.2. And for this I'm going to have 0 minus what? 0. So that is what? 0. Having gotten the pj minus zj, we are going to check if pj minus zj is less than or equals to 0. If pj minus zj is less than or equals to 0, then we have reached an optimum solution. But if you check from this table, you can see that we still have 7 here. Therefore, we have not reached an optimal solution. I want you to note this. For we to reach an optimal solution, this must be satisfied. That is, the value of our net evaluation must be less than or what? Equals to 0. So from this table, we still proceed to the second iteration. Okay. This is my second iteration table. However, before I can compute the data on this table, I still need to determine my key column, the key row, and the key element. Also, I told you from the previous calculation that the key column is gotten from pj minus zj. The value that has the highest value of pj minus zj, the column to which the highest value belongs to, that will be my key column. You understand? The column to which the highest value of pj minus zj belongs to, that will be my key column. And if you check among the pj minus zj's, you can see that 7 has the highest value. The column to which 7 belongs to, that column will be my key column. You understand? So I'm going to circle this column. This is the key column. Okay. To get the key row, I need to get the ratio. And the ratio is gotten by dividing the real activity level by the corresponding key column element. So to get the ratio of these cells, I have to divide the real activity level of the cells, which is what? 200 divided by the key column the corresponding key column element, that is 0.5. 200 divided by 0.5, that is 400. So the value of these cells is 400. Okay, let's get the value of the ratio of these cells. 1300 divided by 7, that is 185.71. 185.71. Okay, let us get the ratio of these cells. I'm going to divide 100 divided by 0, that is 0. So I have gotten the ratio. Now from the previous calculation, I told you that the lowest value, the row to which the lowest value of the ratio belongs to, that will be the key row. You understand? And if you look at this, 185.71 is the lowest value among 400, 185.71 and 0. 185.71 is the lowest value. So the row to which 185.71 belongs to, that will be the key row. We cannot choose 0 because 0 is a neutral number. When you add 0 to a number, it doesn't increase it. And when you subtract 0 from a number, it doesn't increase it. So 0 is a neutral number. So therefore, I cannot regard 0 in this case. So the lowest value is what? 185.71. The row to which 185.71 belongs to will be my what? Key row. You understand? So I'm going to circle from this place to this place. So I have gotten the key column and the key row. The next thing is to get the key element. From the previous calculation, I told you that the element that intercepts both the key row and the key column is known as what? Yeah, it is the key element. So the key element in this place is 7, because 7 is the number that intercepts both the key row, both the key column and the key row. So let me put it here. The key element The key element is what? 7. Okay, now let us proceed with our calculation. Now we are going to have our entry variable and the leaving variable. From this place, I told you from the previous calculation that the entry variable is the variable which our key column points to, and the leaving variable is the variable which our key row points to. As you can see, among our program variable in first iteration we have x2, x3, x5. Those are the program variable in this iteration. So, and if you look at the variable which the key row points to is what? X3. The variable which the key row points to, this is the key row, you understand? And the variable which the key row points to is what? X3. So x3 will be leaving. X3 will be leaving this program variable. And the variable which the key column points to is what? X1. So S1 will be entering and X3 will be leaving the program variable. So, and I told you that for easy computation, it is very, very important that you put your entry variable at the top of your subsequent iteration. So, since X1 will be entering the program variable, so I'm going to have X1 in this place. X3 will be leaving, so there is no need of writing it. I'm going to have X2 and what? X5. So those are the program variable that we want to use. Those are the resource that we want to use. Those are the basics variable that we want to use. You understand? So don't be confused. Okay. Now the CO represents the coefficient of this program variable in the objective function. Don't forget that our objective function is this. So the coefficient of x1 in the objective function is what? 23. So this will be 23. And the coefficient of x2 in the objective function is what? 32. So this will be 32. The coefficient of x5 in the objective function is 0. So the value of these cells will be what? 0. Okay, now let me put zj, then pj minus zj. pj minus zj, which is the net evaluation. Okay, now the next thing is to get the new value for these cells. Don't forget that x1 is our entry variable. To get the new value of row x1, I'm going to divide the key row by the key element. You understand? That is, to get the new value for this row, I'm going to divide the key row, which is this, by the key element, which is 7. So to get the new value for these cells, don't forget that the key row is what? The corresponding key row is what? 1300. So I'm going to divide 1300 by 7. 1300 all over 7, the answer is what? 185.7. So the value for these cells is what? 185.7. Okay, I'm going to divide 7 divided by 7. This will be what? 1. Oh, sorry, I didn't put x1. This will be x1, x2, x3, x4, and x5. Just you understand how I got 185.7. In order to get the new value for the entry variable, you have to divide the key row by the key element. So to get the value of these cells, I just divide 1300 divided by 7, which is what I wrote here, and I got 185.7. So to get the value of these cells, I have to divide the key element, which is 7, by itself. So the value of these cells will be 1. So to get the value of these cells, I'm going to divide these zeros by what? 7. So that will be 0. And the value of these cells, which is the cell for the x3, that will be 1 divided by 7. So let me just put it in fraction. 1 over 7. And for x4, I'm going to have minus 3 over 5 divided by 7. That is minus 0.086. So to get the value of these cells, I'm going to divide 0 by the key element, which is 7. That will also be 0. Okay, now we have gotten the all the value for the entry variable. Okay, to get the new value for the other cells, we have to use that formula that I gave you the other time, which is given by this. The new value, let me represent it as NV, is equals to old value, which is OV, minus the corresponding key row element. multiply by product multiply by corresponding key column element all over the key element. That is, new value is equals to old value minus the corresponding key row element multiplied by corresponding key column element all over the key element. So I'm only going to do the value for these cells. You are going to compute the rest by yourself. Just follow the same approach that I showed you in the first iteration. You also have to follow the same step. You are going to get the value of this cell. So let's compute the value for this. Let's compute the new value for this cell. Don't forget that the old value is what? 200. So I'm going to have the new value is equals to old value, which is 200 minus the corresponding key row element. I'm going to trace this 200. I'm going to trace it to the key row element. So the corresponding key row element is what? 1300. So I'm going to have 1300 multiplied by corresponding key column element. I'm going to trace this 200 to the key column element. The corresponding key column element is what? 0.5. So I'm going to have 1300 multiplied by 0.5 all over the key element. Don't forget that our key element is what? 7. So I'm going to have all over 7. From this, I'm going to have 200 minus 1300 multiplied by 0.5 divided by 7. The answer is 92.86. So 200 minus 92.86, that is 107.14. So the value of these cells is 107.14. So you are going to compute the rest. You understand? So just follow the approach that I used in the first iteration. By using this formula, I got the new value of these cells as this. Okay, let us proceed to calculate the value of our Zj. Okay, let's start with x1. Using the same approach, Zj of x1 is equals to, don't forget that we are going to multiply the coefficient of the objective function with the corresponding variable of x1 and then add the rest together. So for this, I'm going to have 23 multiplied by 1. That will be 23 times 1 plus 32 multiplied by 0. 32 times 0 plus 0 multiplied by 0. Have you seen it? So this is 23. Because 32 times 0 will give us 0. So this is 23. For S1, I have Zj is what? 23. And for S2, the Zj is calculated as follows. Zj of x2 is equals to, we are still going to multiply the coefficient of the objective function with the corresponding variable of x2. So I'm going to have 23 multiplied by 0, that is 0. 32 multiplied by 1, that is 32. And 0 multiplied by 0, that is also what? 0. So the Zj of this is what? 32. Let's get the Zj of x3. That will be 20 multiplied by 1 over 7. Zj of x3, that is 23 multiplied by 1 over 7 plus 32 multiplied by minus 0.071. 32 multiplied by minus 0.071 plus 0 multiplied by 0, that will what? 0 times 0. If you compute this, you are going to get 1. The Zj for this is 1. So let's get the Zj for x4. We are still going to use the same approach. We are going to multiply the coefficient of the programmed variable with the corresponding variable of x4 and then add everything together. So I'm going to have Zj of x4 is equals to 23 multiplied by that is minus 0.86. 23 multiplied by minus 0.86. 0.86. Oh, 0.086. 0.086 plus 32 multiplied by 1.143. 32 multiplied by 1.143 plus 0 multiplied by minus 0.2, that is 0. So if you punch your calculator, you are going to get 2.6. So this is 2.6. So the ZJ of x4 is 2.6. Okay, the ZJ of x5 will be what? 0, because when I add the product of 23 times 0, that is 0. 32 times 0, that is also 0. 0 multiplied by 0, that is also 0. So that is the value of ZJ of x5. Okay, now let us proceed to get the value of the Pj minus Zj. Don't forget that Pj of each variable is the coefficient of each variable, the coefficient of the objective function of each variable. So for x1, the coefficient of the x1 in the objective function is what? 23. So I'm going to have 23 in this place. The coefficient of x2 in the objective function is 32. So I'm going to have 32 in this place. The coefficient of the objective function in the coefficient of x3 in the objective function is what? 0. So and for x4 is also 0. For x5 is also what? 0. Okay, now we can now proceed to get the value of our net evaluation, which is the difference between the Pj and the Zj. 23 minus 23, that is also 0. 32 minus 32, that is 0. 0 minus 1, minus 1. 0 minus 2.6.
Don't forget that
minus
for we to
2.6.
obtain an optimal
0
solution,
0, that is what?
the value of Pj minus Zj must be less than or equals to 0. And if you check from this solution, you can see that the value of Pj minus Zj, all the values are less than or equals to 0. Therefore, we have already reached an optimal solution.
So let us calculate the profit based on the objective function. Don't forget that the objective function is given by this formula, is given by this expression. So I'm going to have 23 multiplied by x1. The real activity of x1 is now 185.7. So I'm going to have 185.7 plus 32 into bracket. The real activity level of S2 is 107.14. 107.14. So if you add this together, you are going to get 7,700. So if it is in dollar, you are going to put dollar. If it is in naira, you are going to put naira. If it is in pounds, you are going to put pounds. So this is the profit maximization. So we have gotten to the end of this of the solution to this linear programming. This is the summary of this solution. When you are given a linear programming problem and you are asked to solve this linear programming problem using the simplex method, the first step is to identify your objective function and the constraints. After that, you are going to change this objective function and constraint into standard form by introducing a slack variable. Don't forget that I told you in this video that the numbers of slack variable that you are going to introduce depends on the numbers of constraints that you have. After changing both the objective function and the constraint into standard form, you are going to prepare your initial simplex table. From the initial simplex table, you are going to get your key column and the key row. After getting your key row and the key column, the next step is that the element that intercepts the key column and the key row will be your key element. After getting the key element, you are going to use your key element to compute the data for the new value of the first iteration that you want to do. After that, you are going to check whether the Pj minus Zj, which is the net evaluation, is less than or equals to 0. If it is less than or equals to 0, then you have reached an optimal solution. But if it is not, then you proceed to the second iteration. If your second iteration, if by the time you compute the data for the second iteration, if you realize that the Pj minus Zj is less than or equals to 0, then you have reached an optimal solution. But perhaps if you realize that the Pj minus Zj values is not less than or equals to 0, then you proceed to the third iteration. Thank you very much for watching the video. Please, I would like you to subscribe to this channel and also hit the notification bell so that when I drop new video, you are going to get updates. Thank you very much.